Welcome back, ladies and gentlemen, to Physical Science with Mr. Kenton. Glad you could be with me today. Want to continue our discussion and our learning as it focuses around the atom. And in the last video, we saw that there were the different models of the atom, and we also talked about the different particles that make up the atom. We talked about the protons, the neutrons, and the electrons. And so now what we're going to do is we're going to look at how can we, as chemists, scientists, how can we use our understanding of those subatomic particles to help us to identify different types of atoms, like what makes an atom of, let's say, carbon unique from an atom of, let's say, oxygen. So that's where we're going to be moving today. So in order for us to properly identify what type of atom we have, we must look at the periodic table. Okay, the periodic table, I would say, is a chemist's most important tool that they have in their toolbox. It's something that chemists go back to time and time and again because there's lots of useful information that we can take away from the periodic table. Okay, and this is just a little bit of information that we can pull from it. For every element on the periodic table, it gives us some valuable information, which includes we can figure out the number of protons and electrons that a specific atom has just by looking at the periodic table. We can determine the average atomic mass that an element has. We can figure out the name of the element. We can figure out the symbol of the element. We can figure out how many energy levels an atom has. We can figure out how many valence electrons it has. Just all these different things that we can figure out just by simply looking at and understanding the information that's on the periodic table. So let's take a look at what you're going to find on the periodic table. So as you can see here, this is an example. If you were to take just one of those very tiny blocks of the periodic table, this is what you should see. And so as you notice here, they've picked carbon. Now, on any periodic table, what you should be able to find is the atomic number, the chemical symbol, the element name, and the average atomic mass of that element. Okay, and so as you can see, you've got the atomic number, which is listed up at the top. In this case, for carbon, that atomic number is 6. You've got the chemical symbol, which is directly below that. For carbon, it's just a capital C, and the spelling is important for element symbols. Always, when you look at a chemical symbol, there will always be one letter that's capitalized, and then the second letter is always going to be lowercase. Okay. Then you've got the element name that's below that chemical symbol, and then directly below that, you have the average atomic mass of that particular element. In this case, for carbon, it's 12.01. Now, that would be measured in AMU for the atomic level scale, and then when you move to the macroscopic scale, that would be 12.01 grams of carbon in 1 mole of carbon. Now, we'll talk more about those things as we move forward, but that's just a bit of the information that we can take away from the periodic table. Now, as we move forward, I want us to break down what information does the actual atomic number, what does it actually tell us? Like, what does that even mean? And so the atomic number, you will commonly see it referenced as a capital Z. So if you see what is the Z for an element on the periodic table, it's asking you what's the atomic number for that element, okay? Well, then you might be asking yourself, well, Mr. Kenton, what's the atomic number? Glad you asked. The atomic number is going to be the number of protons that are in the nucleus of an atom that we're looking at. Okay, and so if you think back to the previous slide, for carbon, it had an atomic number of 6. Now, what that is telling you and me is that carbon has 6 protons in its nucleus. Okay, now, even more importantly, because this atomic number tells us the number of protons, this tells us what element that we actually have. So all atoms of the same element have the same number of protons. So for our carbon example, that means if you have a carbon atom, it doesn't matter what kind of carbon atom it is, it must have 6 protons in order for it to be classified as carbon. As soon as you change the number of protons, you change the identity of the element that you're dealing with, okay? Now, the atomic number also tells us the number of electrons an atom has. Now, I want to be very specific here because when we talk about an atom, we talk about these tiny particles that are the building blocks of matter. Atoms, for the most part, well, in our case, atoms are always going to be electrically neutral. Now, when I say that an atom is electrically neutral, what I'm saying is that the number of positive particles that it has to equal the number of negative particles that it has. Okay? That's what it means to be electrically neutral. There is no net positive or net negative charge in our overall atom. So again, I'm going back to the carbon example. We just saw in the previous slide that carbon has 6 protons. That means that a neutral atom of carbon must have 6 electrons. If you think about the charges, 1 proton has a positive charge, 1 electron has a negative charge, so 6 positive charges minus 6 negative charges gives us 0. Okay, please remember that in a neutral atom, the number of protons and the number of electrons will always be the same. And we can look at the atomic number to help us identify the number of protons and the number of electrons in an electrically neutral atom. Okay? Now that I've communicated that with you guys, I want you to use your periodic tables. I want you to find those elements, and I want you to tell me how many protons and electrons do the following elements have. Okay? Good luck.